So now that we've talked about the performance of this program, let's take a look at how it's implemented. And this shows off a lot of really, really cool things. So first of all, we're going to define our own functional interface called a quad function, which just takes 4 parameters to the apply method and returns a value of type R. And you'll see why we need this later. So think of a quad function as a bifunction on steroids. It's got 4 parameters instead of 2. We're going to run the timing tests, a certain number of iterations. We pick a 10. Here's the file that contains the complete work of Shakespeare. So if you go over here and you click on the resources tab, you'll see, lo and behold, here's the complete works of Shakespeare, if you ever wanted to read them all. And then we have this really fun regular expression here. It's called white space and punctuation. And this corresponds to white space characters and punctuation that appears in the complete works of Shakespeare that we want to ignore because we only want to deal with words. And you'll see how we use that in a second. Here's the main program, the entry point into the whole test. We print out the number of cores that the Java execution environment thinks we have. In my case, it thinks there's 16, even though there's really 8 because they're hyper-threaded. We warm up the fork join pool just to get everything up and loaded in memory. And then we run 2 types of tests. We run tests using hash maps for concurrent and non-concurrent collectors for sequential and parallel streams. And then we run tests for TreeMap using concurrent and non-concurrent collectors for parallel and sequential streams. And when we get into the implementation, you'll see some super duper clever refactoring that I did here to make this code infinitely parameterizable. So we only have to write everything one time. There's no unnecessary duplication of logic. Now, the main thing that's the workhorse here is this method reference called time stream collect. So let's go take a look at that. So here's time stream collect. You can see that time stream collect takes 4 parameters. The type of the test, which is either going to be, hash map or tree map, whether or not we want to use a parallel stream or a sequential stream, the list of all the words in Shakespeare as strings, and then the collector that we want to use, which is either going to be the collectors to map collector, which is what comes out of the box with Java, or the concurrent map collector, which is what we've implemented here. So that's parameterized and passed in as a parameter to this. So the first thing this test does is it runs the garbage collector. It then determines the name of the test. So it's either parallel or sequential in the type. So it could be like parallel, concurrent, parallel concurrent hash map or sequential, non-concurrent tree map or whatever. And then we use our little time run method that we've looked at a million times that basically takes a snapshot of how long it takes to run the test and sticks it in a hash map for later use. And then we iterate for the number of iterations, and we make a call to a helper method called getResults. It passes in the Boolean to indicate whether we want it to be parallel or sequential, the list of words, and the collector. So let's go take a look at getResults. This is a fun little test method that will take all the words of Shakespeare and turn them into a sequential stream, which of course uses a split iterator internally. And if we've got the parallel flag set, we convert that sequential stream to a parallel stream. So this allows us to dynamically toggle what kind of stream we're going to have. And then what we do is we say, for each of the words in this stream, go ahead and map each of those words to lowercase. So they're all in a canonical case ordering. And then the last thing we do is we just collect the results into whatever collector was passed in, either the conventional map collector that comes out of the collector's utility class or our concurrent map collector, which we implemented. So you'll notice that this code, again, is highly factored. We parameterize everything that matters. And as you can see, it gets run for basically n times, where n is the number of iterations we want to have. So that's the thing that's actually doing the work. The rest of this stuff, which is passed as parameters to run map collector tests, are parameters that will influence what gets called. So we're going to pass in the key mapper, which figures out what the keys should be. Now, keep in mind that what we have here is a stream of strings. And so we want the keys to be the strings themselves. So we use the identity function for that. The value is more interesting, however. And what the value is going to be is it's going to be set initially to 1, because we're going to keep track of how many times each word appears in the complete work of Shakespeare. So we're going to take advantage of the fact that there's only unique keys, and then we're going to use the value field in the map to keep a running count of the number of times we get merges that collide. So whenever there's a merge collision on the key, we simply increment the value by 1 to indicate there was another use of that word. Then we pass in factory methods or constructor references for the non-concurrent map and then for the concurrent map supplier. So we make a hash map and a concurrent hash map for this particular run of the test. And then down here, we have everything the same, except we're going to use TreeMap as the concurrent and non-concurrent collector final type. You'll see how that gets used in a second as well. So that's how we basically run these collector tests, or we configure the collector test. Here's the run collector tests test method. This is kind of the driver, if you will, for the tests. You can see it takes a bunch of parameters: the test type, the key mapper, the value mapper, the non-concurrent map supplier, and the concurrent map supplier. And then it takes this quad function, which is going to be used to actually indicate how to do the computation. So the quad function just has 4 parameters. That's why it's a quad function. Now what we do, now we're finally getting into the nuts and bolts of this. So we use the as-list method on arrays to create arrays or create tests for different sizes of input data. And I probably could have used, like, I don't know, list .of. That would probably have worked too, but I just used arrays as list. So we're making a 1,000, 10,000, 100,000, and a million. That's the limit for each of these things. Then we come down here and we make a call to this get input method, giving it the complete works of Shakespeare and that crazy regular expression that I showed you up here of white space and punctuation. And what this method does is it goes ahead and will load in the file containing the complete works of Shakespeare, read everything in as a giant string, and then we're going to use that crazy regular expression to split that string by compiling it into a regular expression that will ignore all the white space and punctuation and only create a stream of words. So we have a stream of words, we get rid of any empty words, and we only handle up to limit of them, and then we collect the results into a list. So this is a really nice, very simple example of using regular expressions with split as stream, which came along in Java 8, in order to be able to convert the input file into a stream of words. We then take that list, because we are going to have a list of these strings up to a certain limit, like 1,000, 10,000, 100,000, a million. We print out a diagnostic, and then we start applying all the various tests. So you can see here that we apply first the non-concurrent test, which would be, say, non-concurrent hash map. And for non-concurrent hash map, we would then pass in false, because we don't want to have a parallel stream. We would pass in the toMap version that comes from collectors, which is just a hash map in this case, which is what we get from map supplier. And then we're going to have a parallel stream here. So now we have true, but again, we're going to use the map, whatever the map supplier is going to be. And then down here, we're going to end up having concurrent. We're going to use a concurrent hash map, which in this case is going to be the concurrent map supplier for a sequential stream, but we're going to get the concurrent map supplier to work with our concurrent map collector. And then the final thing is we're going to make a parallel stream that uses a concurrent collector. So you notice we make all these calls that are heavily parameterized, so we only have to implement anything one time. And then when we're all done, we go ahead and print the timing results. So that's basically how the program works. I think it's really, really cool. It shows off a lot of very interesting Java 8 features, modern Java features with functional programming. It uses some customized functional interfaces. It uses very advanced uses of things like collectors. And as we saw when we looked at the results before, we get some very interesting results. And again, just to recap very quickly, the main point to take away from this is that using concurrent collectors for this kind of application is a win. And the reason it's a win is because synchronization costs in a concurrent parallel stream for this particular configuration and types are lower than merging costs for things like tree maps. So merging is more expensive than synchronization for this particular example.